Okay, last time I mentioned the last method, which is for polynomial equations, and that finds all the roots of the polynomial equation at the same time. Uh, the method works uh, to develop a table.
सर मेरे क्वेश्चन है लास्ट क्लास से।
जी जी, बोलिए।
सर आपने लास्ट क्लास में बोला था कि मलर्स मेथड इज़ द बेस्ट मेथड अगर आपको रूट फाइंड करना है, अभी तक जितने पढ़े हमने उसमें से, तो उसका क्या रीज़न था?
उसका रीज़न थ्योरेटिकल है, प्रैक्टिकल नहीं है। थ्योरेटिकल ये है कि most of the functions that we have in any nonlinear equation, we say nonlinear equation. The function involved is nonlinear. बाकी मेथड्स जो हैं या तो स्लोप ऑफ टेंजेंट निकाल के जरिए काम कर रहे हैं या सीकेंट लाइन के जरिए काम कर रहे हैं. दैट मीन्स क्लोज टू द रूट we either consider tangent line or secant line. For that reason, all these methods are can be classified under the heading of linear approximation. Whereas Mueller's method में हम straight line इस्तेमाल नहीं कर रहे, बल्कि close to a root we are in fact using a parabola. And parabola is a quadratic function. That means now we assume that the function behaves as a second degree polynomial, uh, and our approximation can then be termed as a higher degree approximation. So theoretically, a higher degree approximation, when you assume that function fx is behaving as second degree or third degree or fourth degree, you are theoretically supposed to have better and better results, or more accurate or more or rapid results. That is the reason that I said that Mueller's method is the best method considered up to now. Is it clear?
यस सर, यस।
अच्छा साहब, so Curie algorithm is used for finding all the roots of a polynomial equation of this type at the same time by developing some table of numbers uh, which has columns headed alternately E and Q. So if you have a fourth degree equation, as I will be considering in the next on the next page, we will have uh, four columns of Qs headed Q0, Q1, Q2, Q3, and four columns of E's in which the first column of E and the last column of E will always have a value 0. How the rest of the values in the table is developed are placed. For first row of Qs, we use uh, coefficient of the third degree term divided by coefficient of the fourth degree term and taking negative of that. So this divided by this is minus 0.2 and the negative of that is plus 2. The first row of Q will have a first element developed using the coefficient of the third degree divided by the second degree, fourth degree, uh, and all the rest of the elements in the first row of Q will be zeros. Whereas the first row of E is developed using, again, coefficients of this polynomial equation. But remember that the first value uh, of E and the last value of E in every row of E's will be zeros. The other values are then filled by numbers uh, ratio of second degree term coefficient to ratio to the third degree term. So minus 32 divided by minus 256 gives us this number. Then, sorry, 160 divided by minus 256 gives us this number. Then minus 32 divided by 160 gives us this number. And 1 by negative 32 gives us this number. So first row of Q and first row of E are directly developed using the coefficients of unknowns in the given polynomial equations, the way I had described. Whereas the rest of the rows are developed in a different way that I told you in this algorithm. Every new Q value is developed using the above two E values difference added to the last Q value. Similarly, a value of E in any column is developed using the ratio of the above two Q values multiplied by the last E value. Using this algorithm, you can say that the calculation goes like this. Oh, this annotation is not in control. Sorry, I just use my cursor to indicate after closing this annotation. I have to produce after one row of Q and one row of E, I have to produce one row of Qs. अब Q की जो ये रो डेवलप हो रही है, ये कैसे डेवलप हो रही है? ये नंबर 1.37 is obtained by this number minus this number plus this number. Next value of Q, this number, the value of E on the right minus the value of E on the left plus the value of Q in the last development of Q. This Q value is produced by this E value on the right minus this E value on the left added to the last Q value and so on. When I go to develop the values of E's in the next row, so we consider what? The value of Q just to the right divided by the value of Q just to the left multiplied by the value of E is the last value of E. The next Q value, and we make this number using this number, which is the last Q or latest Q value on the right divided by latest Q value on the left multiplied by the last E value and so on. In this way, we develop this table. I hope you understand the construction of the table clearly now. Note that third column E का है, fourth column भी E का है, sorry, fifth column or seventh column E का है. Or in this column, in these columns, if and when we observe that the values of E's are going to become smaller and smaller, then we have to draw some conclusions. To draw the conclusions, we need to note down these points. First and the last column of E always contain a 0. The values in each of the other column of E are converging to 0. So E1, E2, E3, they are converging to 0. When this point 2 is clearly observed, as it is clearly observed here, we note that the values in each of the 4 columns of Q are clearly converging to some number. ये number जो है going to some number, this number is going to some particular number, because the difference of the values appearing in the columns of Q, last value minus the previous value, the difference is very small. So all the columns of Q will converge in case all the columns of E converge to 0. Now, columns of Q किस पे converge कर रहे हैं? They are clearly converging to some number that indicates the approximate values of roots of the polynomial equation under consideration. So, thus approximate roots of polynomial equation this are 0.98, I take 2 decimal, 0.673, 0.307, and 0.038. This is how we draw conclusion from this table. Now, you must note that in this particular example, every column of E was converging towards 0. So every column of Q is uh, required to converge to some number. हमने इन numbers को R1, R2, R3, R4 के तौर पे note down कर लिया as approximate roots of the given polynomial equation. अगर आपको इन roots की further accuracy चाहिए, so you can switch to some other method. You can proceed using Newton's method, taking the initial approximation as indicated by the above values. मगर ये काम फिर आपको हर वैल्यू के लिए अलग अलग करना पड़ेगा. इसका मतलब है इस पे न्यूटन मेथड x नॉट लेके न्यूटन मेथड लगाएं एक दफा तो इस रूट की एक्यूरेसी आ जाएगी. Then take this as x naught and start Newton's method again. So इस की high accuracy value आ जाएगी and so on and so forth. So that completes the description of QD algorithm. मैंने recording on कर दी थी? Yes, it is. Now, when I discussed the nature of polynomial equation previously, I mentioned that some of the roots, any nth degree polynomial equation will have n roots. They may all be same. Some of them may be real and repeated. Some of them may be complex. Whenever there is a complex root, it appears as a conjugate pair. So if we consider any equation that has a conjugate, that has complex roots, this method works exactly the same as previously. So I consider an example जिसमें मैं जानबूझ के एक पोलिनोमियल अपनी तरफ से बना रहा हूँ जिसका एक रूट 1 है क्लियरली, एक रूट 4 है क्लियरली, मगर ये एक क्वाड्रेटिक फैक्टर ऐसा है जिसके कॉम्प्लेक्स कॉन्जुगेट रूट्स हैं. इन सबको मल्टीप्लाई करके मैंने ये पोलिनोमियल इक्वेशन बना दी और अब इसके ऊपर मैं QD एल्गोरिथम लगाऊंगा. यहाँ पहली रो में सिर्फ इस पोलिनोमियल के कोएफिशिएंट्स लिखे हुए 1, -6, 1, -6, 12, -19 and 12. 1, -6, 12, -19 and 12. तो ये जो पहली इस टेबल में पहली जो रो है इसका QD एल्गोरिथम से सिर्फ ये ताल्लुक है कि हमने इन कोएफिशिएंट्स को यहाँ लिखा है. उसके बाद Q की पहली रो कैसे डेवलप होती है? x³ का कोएफिशिएंट डिवाइडेड बाय x4 का कोएफिशिएंट, उसका नेगेटिव. Q की पहली रो में बाकी सारी वैल्यूज 0 हैं, whereas E की पहली रो में फर्स्ट एलिमेंट 0, लास्ट एलिमेंट 0, rest of the elements. 12 divided by -6 gives you -2. -19 divided by 12 gives you -1.58. And 12 divided by -19 gives you -0.631. After these two special rows developed as desired, next row of Q, note that हम Q's की एक रो बनाते हैं, फिर E की बनाते हैं, फिर Q की बनाते हैं, फिर E की बनाते हैं, and so on and so forth. So first row of Q is made from the coefficients of third degree and first degree terms. The rest are zeros. But the next row of Q is developed by what? This number -2, -0, plus previous Q value, that is 4. Next Q value, this minus this plus this. Next Q value, this minus this plus this. Once a row of Q is completed, we switch to the development of the next E rows. Row of E will always have first and last element 0. Elements in the row of E are developed as the latest value of Q on the right divided by latest value of Q on the left of the number that we are considering. जो भी रिजल्ट आएगा इन दोनों की रेशियो का, उसको इस नंबर यानी प्रीवियस वैल्यू ऑफ ई से मल्टीप्लाई करके ये रिजल्ट हासिल हुआ. दिस नंबर इज डेवलप्ड यूजिंग last value of q on the right divided by last value of q on the left multiplied by previous value of e, and so on. If you have understood the development of the rows, keep on doing that, and you can use Excel sheet to development of this, because lots of calculations are there, repeated calculations are there. देखो मैंने E2 का जो कॉलम है इसको कलर किया हुआ है. इसकी एक वजह है. रिमेंबर दैट हमने इक्वेशन ही ऐसी बनाई है जिसमें कॉम्प्लेक्स कॉन्जुगेट रूट्स हैं. तो इसकी इंडिकेशन जब हम QT एल्गोरिथम लगाएंगे तो इसकी इंडिकेशन कहाँ से आएगी? इसकी इंडिकेशन से आएगी कि हम देखेंगे कि हर ई का कॉलम जो है वो पिछले वाले क्वेश्चन में तो 0 की तरफ जा रहा था, इस दफा E1 कॉलम और E3 कॉलम ये तो 0 की तरफ जा रहे हैं, मगर E5 कॉलम, मगर E3 कॉलम जो है जिसको मैंने कलर किया हुआ है वो 0 की तरफ नहीं जा रहा. It's diverging, it's fluctuating. So that gives us an indication of presence of a complex root. In fact, a pair of complex roots. To develop that pair of complex roots, हम क्या क्या इस्तेमाल करते हैं? हम Q values इस्तेमाल करते हैं, the latest and the previous. और कैसे इस्तेमाल करते हैं? The column of Q0 is converging to a real root 4. This is column Q0. And the column Q last is converging to the real root 1. QD algorithm में ऐसा होने था कि real root जो है वो तो आ जाएगा. To extract the complex root, we look into the column of E2, and that is not converging to 0. E0, E1, E2, that is not converging to 0 and has a fluctuating values. To obtain the quadratic factor that will ultimately produce the corresponding complex conjugate root, we use the following trick. The trick is take the sum of Q values, latest or the previous, from the columns Q1 और Q2 जिसके बीच में E का कॉलम डाइवर्ज कर रहा था, and add them. In fact हमने ये दोबारा लिख दिया, sum लेना था, sum of Q values ले लिया. This gives approximate value of R in the complex conjugate root that are going to be produced by x square minus Rx minus S. तो R की वैल्यू कैसे बननी है? Taking the sum of the last values of Q's on either side of a converging column of E. Then product of Q to the left and above the last E. अब ये कौन से वैल्यूज की बात हो रही है? इस नंबर की और इस नंबर की, यानी value of Q, which is the second last value,